Welcome back to Explaining Everything, the channel where we dive into the stories and mysteries behind everyday things. Today's question comes from one of our curious viewers, Chicken Jockey 101. Thanks for the suggestion, Chicken Jockey. You asked, how does gelatin turn from powder into jiggly dessert? If you've ever made gelatin at home or just poked it for fun at a buffet, you've probably wondered, wait, how does this dusty powder become something that wiggles like it's alive? Today, we're diving into the weird, wobbly world of gelatin, breaking down how this unassuming pantry item pulls off one of the most oddly satisfying transformations in the culinary universe. So if you've ever stared at a jiggly dessert and thought, okay, but why? You're in the right place. Let's get into it, right here on Explaining Everything. First off, if you've never seen dry gelatin powder, it looks like something you should not put in your body. It's beige. It's grainy. It smells like absolutely nothing. And yet, with hot water and time, it turns into the shimmering food of birthday parties and retro cookbooks. How? Gelatin is made up mostly of collagen, which is a protein found in connective tissues of animals. Yeah, we're starting with that fun fact early. So, technically, every time you eat gelatin, you're chewing on boiled-down cow or pig bits, reimagined as a fruit-flavored trampoline. But don't worry, it's way less horrifying than it sounds. The collagen is processed into gelatin, which is cleaned, filtered, dried, and turned into that powdery form. So by the time it gets to your pantry, it's basically just long chains of protein that are itching for a glow-up. Here's where the transformation begins. You dump the gelatin powder into hot water, and it seems like nothing's happening. But deep in that bowl of future dessert, something magical and kind of nerdy is going on. The heat causes the protein chains in the gelatin to unwind, kind of like when you come home from work and immediately unbutton your pants. Those tightly coiled protein strands relax and become loose and wiggly in the hot water. It's called denaturation, which sounds like a medieval curse, but it's just science speak for unraveling. Now, while those proteins are floating around like retired jump ropes, they're also interacting with water molecules. And here's the cool part. As the mixture cools down, those proteins start to reconnect. But instead of coiling back up into their original tight shapes, they form a mesh-like network. Think of it like a game of Twister, where all the proteins are linking arms, legs, and probably some elbows. They trap the water between them, creating a gel, soft, springy, and just jiggly enough to make you question if it's entirely solid. Gelatin jiggles because the mesh it forms isn't rigid. It's flexible and elastic. It's kind of like a net holding water balloons. It keeps everything together, but it can still wiggle when poked. And the more gelatin you add, the denser the network becomes. That's why some people make those ultra-firm cubes that bounce if you drop them. Don't ask how we know. While others make the soft, melt-in-your-mouth versions that collapse under a spoon, like drama queens. Temperature also plays a role. Gelatin solidifies as it cools below around 15 degrees Celsius to 20 degrees Celsius. That's 59 degrees Fahrenheit to 68 degrees Fahrenheit for everyone living in a Fahrenheit fantasy world. Below that temperature, the proteins lock into place. Above it, they loosen up again. That's why gelatin melts in your mouth. It's literally softening from your body heat. Ever notice that every gelatin recipe starts with sprinkle the powder over cold water and let it sit for a few minutes? That's called blooming. And no, it's not about flowers or your spiritual journey. Blooming is just giving the gelatin time to soak up water before you add heat. It allows each tiny grain to fully hydrate and swell up. If you skip this step and dump the powder straight into hot water, it clumps into a gloopy mess that looks like the failed experiment of someone trying to make edible cement. Once set, gelatin is kind of see-through. Not entirely, but enough to make you wonder if it's the only food that looks like it could double as a contact lens. That's because the gelatin network is arranged so neatly that light can mostly pass through it without bouncing around too much. It's like a microscopic game of don't touch the walls that light mostly wins. That's why those rainbow-layered gelatin desserts look so mesmerizing. They're basically edible stained glass. Gelatin is weird. It's the only food that makes you question both texture and physics in a single bite. But the transformation from powder to party snack is pure protein wizardry. No baking, no frying, no sorcery, just proteins doing yoga in warm water and then hugging each other as they cool down. So next time you see a bowl of Jell-O wobbling dramatically on a plate, remember, you're looking at a masterpiece of molecular architecture. A protein-powered water trap that just wants to be admired, poked, and maybe topped with whipped cream. If we made you crave those jiggly gelatin, don't forget to like, subscribe, and indulge in the chemistry, physics, and wizardry of Jell-O. Also, if you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for tuning in, and join us next time here in the channel that answers all the why, what, who, where, and how questions you've always wondered about, here on Explaining Everything.